Hi everyone, this very brief lesson is just on function notation. So in the previous lesson we learned what a function was. Today we're going to talk about how to write it down, the official way to write a function. Okay, here's what it looks like. This right here, f and then the x in parentheses, that's called function notation or f of x notation. So just a couple of things I want you to know about this notation. And some of these more historical items I just know are going to come up on your homework assignment. That symbol is read f of x. So when you hear me saying f of x, that's this, okay? And I'm saying this is a function of x. So remember how we talked about that a little bit yesterday. This lesson, I should say. The parentheses in this case are just part of the symbol. They do not mean to multiply. This is not taking f and multiplying by x. It is a function of x. So in this case, parentheses are not multiplication. This notation was created by a Swiss mathematician by the name of Leonhard Euler. That is pronounced Euler. And this guy Euler was sort of the founding father of our modern algebra type classes. So you can thank this guy for sitting through this class this year. He came up with a lot of the basis for our current system of doing algebra. He was around way back when, 1707 to 17, and he, as I just said, is most well known for writing a bunch of algebra books. Okay, he sort of discovered the system. He created the symbols that we still use today. This stuff is a big deal to him. So just keep that in mind. Okay, so for example, this first one would be pronounced or would be read t of x equals x. T of x equals x. Here I would say b of x equals x squared over 20. Okay, so really this b of x, t of x, that's what I want you to get used to. I know it's not an f this time. You can really use any letter you want for a function. Sometimes people switch it depending on, you know, if they're talking about, I don't know, money, they might use D for dollars, or they might use Y for years, things like that. Okay, so there's different variables that can be thrown in there, but it is still function notation. And so here's how function notation works. It says use the function b of x equals x squared over 20 for the following. Oh, didn't mean to have that there already. Okay, so when I say evaluate b of 45, if you compare that to this, do you see that the 45 is now just in place of the x? So what that wants you to do is literally put the 45 in place of the x in the equation part of the function. That's telling you take your x and replace it with a 45. And so you'll see that's what I did right here. Is I took that x squared over 20 and I just put a 45 in place of the x. And then that I can just type straight into a calculator. 45 squared over 2 is equal to 101.25. Okay. Same thing with negative 10. Negative 10 I'm putting in place of x, so that means I'm going to write it, I did it again. I'm going to write it as negative 10 squared over 20, and that I do want to mention, I mentioned this in the previous lesson, you have to be careful when you're squaring negative numbers in your calculator. In your calculator, anytime you are going to square a negative number, that number needs to be in parentheses. So negative 10 squared would be 100, and then 100 over 20 would give you 5. But that's all there is to it, is taking, whoops, sorry about that, taking this number and plugging it in place of x. Okay, so again, they're giving you a function. If f of x equals 24 plus x over 2x squared, evaluate each of the following. So f of 4, that's telling you, okay, plug 4 in for x. Like this. Notice I just took this x and this x, replaced it with 4. So 24 plus 4 over 2 times 4 squared. In your calculator, if you want to do this all in one shot, you can. I would put this top part in parentheses and probably this bottom part in parentheses. Or you could do the top and the bottom separately and then just divide. Way you should come out to 0.875. Okay, as long as you can get the idea of plugging the number in, I think you'll be okay. And if you think back to that first worksheet we did, Lesson Master 1-1, I was giving you things like you know, y equals x squared plus 4, and then I was telling you things to put in place of x. That's the same thing. So now I'm going to take negative 8 and plug. It's going to look like this, and of course I'm going to remember to put my negative 8 in parentheses when I want to square it. And let's see, if you were to do that in your calculator, I would do this in parentheses, with one big division sign in between them. Should come out to be 0.125. Now don't let this next one throw you off because it's a letter, so it's weird, but it's still just telling you put that z in place of both of the x's, okay? So that's going to look 24 plus z over 2 times z squared. Nothing you can really do with that. You can't combine anything. You can't cancel anything out. The only thing I could maybe do is write this a little bit nice. 24 plus z over 2z squared. That's all you can do. And that's your answer. Okay, you replace the x with the value, and then you simplified it as much as you can. Let's do the same thing with 3z. Now what I do have to be careful of with that 3z is that entire thing, the entire 3z is going inside these parentheses here. It's going to look like this. And then down here, I can do 3z squared. 3z squared means to do 3z times 3z. Well, 3 times 3 makes 9. Z times z makes z. So this would come out, this little piece right here becomes 9z squared. And then I can still combine the 2 and the 9. So 2 times 9 is 18. That's going to look like this. 24 plus 3z. So again, I put this 3z in place of this x up here too. And then I simplified the bottom to become 18z squared. But that's really all you're doing in this lesson, is you are taking numbers and plugging them into the functions for x. Okay? That's all there is to it.